Yeah.
I mean, this was.
And you know, you
This was a
just
surprise.
what if you had 4 on the table instead of 1?
Yeah.
They're just sitting in this room.
Click the button, you're
You know,
done.
little folder. I mean,
Yeah.
I'm sure he's frustrated,
really? So.
but he's not one to walk away from a challenge.
4 or 5, use one you
No,
want.
I'll frustrate. You
Assume
know,
as it matures as a program, you
stuff
know,
like
a lot of
this.
it's
You
gonna
know,
be stuff you run
it sounds
into,
like
you
you
know.
just said, "Screw
I'm
this."
sure he's
you
probably
know.
happy that you're giving feedback.
It's kind of fun. I'm excited. I think it's a good product, and I'm excited to be doing something that makes it better. Just the same way that any open source person would be excited to be contributing something.
Yep.
Did you see
And
any
I said to
discussion
him, I
of
said, well,
possible
I said,
replacements?
I'll do this for you, but I only have.
I've heard
I have
two.
a
One,
requirement. He's
obviously,
like, "What's that?"
Narduzzi would
I said,
be
"You gotta
great
put
to
my
have
name
back
in the
from
header
Pitt.
and say, "I worked on it."
And then there's a guy named Luke
So we'll see
Fickle,
what it does.
I think.
What's he doing? there?
He's the head coach at Cincinnati,
Never actually
which is funny because that's where
contributed
Dantonio
to an
came from.
open source project.
Oh,
And apparently,
It's on my
Dantonio
list.
and Fickle were assistant coaches together at Ohio State under Tressel, I
Time for
think.
pizza.
And Fickle has Fickle was at Ohio State as an assistant, also under Meyer. So I mean, the guy has a good background that's fairly similar to Dantonio's background. So hopefully, philosophically, they'd be halfway similar.
yeah, and if he's still got a role with the university, I mean, he'd be around to, help.
So I mean, the only thing that I've ever heard anybody complain about with Dantonio is just that the offense has struggled so much. But and it seems like when our offense has done well, it's been because we've had quarterbacks that audible half the plays. You know, from what I understand, Connor Cook was changing the play like 3/4 of the time.
Oh, really? Oh, wow. I mean, I just see what some of those quarterbacks do now in the NFL that he had.
Yeah.
That came through the program. I mean, they're like awesome.
We've had a hell of a string of quarterbacks.
Yeah. So how he did that, I don't know, but
Yeah.
he really developed them well.
So we lose those quarterbacks that were doing all that play calling themselves, and you're left with the plays that are actually being called, and you can't move the ball.
So that's a light amber ale that was brewed specifically for Dew Point by Lansing as a brewery.
What's that?
The can, that's 32 ounces of amber ale that was brewed specifically for Dew Point by Lansing Brewery.
You guys want to have a keg of it?
It's actually really
We have
good. And it's on
17
tap
kegs
at
of
the
it.
brewery.
Oh, really?
And they canned some of it. I think about 16, 17 kegs is the minimum production run. So yeah, there was a little after-work party last week where they tapped my kegs in the back room and said, you know, if you're a Dew Pointer, come on over. Yeah, it's free.
All the Dew Point advertisements all over at the basketball game the other night. Yeah.
It's good, good PR, isn't it?
We're at football games saying it all the time too, going around there. In fact, my wife is like, the official IT,
You can be the official whatever you want, as long as you give them that money.
yeah, that's kind of what I was thinking too.
So somewhere out here, so right there in the middle there, there's a sign-in sheet. If you don't want to put your full name, you don't have to. But if you do want to get on the mailing list for the Lansing Code's newsletter, just throw an email on there. But at least put a name, even if it's just your favorite fictional name or something, just so we have a count for our sponsors and such.
Paris Hilton.
Well, if that's all you gotta do, then it'll be Elsa and whoever. This is the first.
Bingo sheets.
Yeah, it should be hopefully plenty of bingo sheets. I printed off 30 and I think 20 RSVP, and not usually all that RSVP show up. So.
Feel free to grab that pen if you need to during the.
my first time all year having a pumpkin. I bought a case of this one year because it was very, very limited in distribution that year. And one of my former coworkers, she and her husband own Vinyl.
I don't think so. Go ahead.
They're by Jolly and Okemos, kind of like right by the Taco Bell.
Yeah.
That strip mall on the same side of Jolly as Taco Bell.
Yeah, I told
Right,
you were getting that
basically on the end closest to Taco Bell, there's Vine and Brew there. And they
Yeah.
have a bunch of
Model S.
really high-end
Maybe one of the new
Stuff, some pretty
electric
good
trucks with
noticed
a
it.
pointed
Oh,
roof.
yeah?
Yes.
And I passed
That was
it every day.
quite a good
Yeah, it's-
construction mine.
It's pretty cool. They,
Nice to see you at a
Well,
Detroit
Cybertruck.
meeting, Jim.
TechSmith
I don't think I've ever seen you here.
No, it's my first one.
behind them, and they have like a Slack bot.
I told Rob, I said the commute was awesome. I walked from across the hall because that's where my desk
That's why I
is.
never-
Either the
surprised I never
Twitter
saw
or
you
the
here,
Facebook
you know?
account of
That's
Vine
across
Brew,
the
and the
hall.
moment they announce
I know when he said
anything, it
when
like
they put it on
sends
their
it.
afterwards, I thought there was
You know, and they,
chance.
so a lot of stuff. The moment it gets there, it's gone. It's their fault.
I still got my son in college, so I can't hang out too long. But
Okay.
he said he's good till 10:30. So I don't know if I am, but he is.
There you go.
So we'll probably get kind of a slow momentum toward going in another couple minutes here. I'll kind of
Can I-
also come and grab some
Before you launch into the full body of it, can I have 2 minutes to introduce Klugnet?
Absolutely.
Okay. Okay.
I actually spent way more time than I should have trying to fix the intro slide for, there's the lansingcodes.com or the lansing.codes/slide or something like that. And it's supposed to give you like a rotating thing of all the different meetups coming up, but it's broken. Somebody didn't renew a domain name.
Oh.
So it's hosted somewhere
Well, that
else.
never
I can
happens
figure
unless
out.
you're Microsoft.
Yeah. No, that's just the certs.
That was cert. That was a cert. Yeah, that's true.
It was nice to know that it wasn't our fault.
Well, it's nice to know they pay attention to their certs.
Yeah.
What if Microsoft didn't renew their main server or something like that?
Yeah, we're going to have
Oh, okay.
Teams went down because they forgot to renew one of their SSL certifications.
What happens?
Microsoft looked very good, but
Yeah.
Hi, here, Freeman.
Nice to meet you.
You too. Yeah, I noticed your email address. You had MSU.
Yeah.
Yeah.
Yep. I'm in the last semester of my bachelor's, but also already working on my master's.
Okay. Yeah, you know, you knew a lot about the Dantonio stuff, so I'm going like, man, where is this on the
Yeah.
web?
Yep. Although my brother, who lives in New York, texted me about it before I saw any, and I started Googling. I was like, where did he get this from? But I guess he's got his finger on the pulse.
Oh, man. Yeah, my son, he's a MSU grad. And he's got his finger on the pulse, but he's in Utah this week. So,
Well,
all right, so fill me in. What happened?
Dantonio resigned.
I did not know
He's
that.
going to stay with the university in some sort of special role at
How's it
consulting or goodness knows what.
Football coach emeritus.
Yeah. Yeah.
How are you?
So he says, quote, I'm a Spartan for life.
Well, I think a lot of people saw it coming, though, didn't they?
I mean, I guess the last time he was asked, he said, I live moment to moment, but right now I'm planning on being the head coach in 2020. So, no, the top two names that are being floated to replace him are Pat Narduzzi, head coach
Okay.
at Pitt, former defensive coordinator here, and
I recognize the name, Ray.
yeah, and he was an amazing defensive coordinator, absolutely phenomenal. And a guy named Luke Fickle, who was the head coach at Cincinnati and was an assistant coach at Ohio State when Dantonio was there and coached under Tressel and Meyer both. So obviously is used to being around big time programs.
Well, anybody can bring a little Ohio State here would be good, but only a little.
But a similar pedigree with maybe a different offensive scheme would be nice. You know, hopefully that same commitment to defense and building character and commitment to doing things the right way and all that kind of stuff. Just a little bit more zip on the offensive side of the ball.
And the promise to keep playing in the fourth quarter.
Yes.
Yeah, that'd be nice.
Mm-hmm.
All right, so if you want to grab any food or drink last second, we'll go ahead and get started here. And before we get going with the core topic for tonight, I wanted to give Joe a moment to talk about some upcoming stuff for GlugNet.
Okay, so I see some faces here I don't recognize, which is great. Not surprising since this is my first time at this kind of meeting. But you may or may not be aware, Lansing has many, many tech meetups. As we were mentioning earlier, there's over 20 for this month alone. One of those is called GlugNet, G-L-U-G-N-E-T, stands for Greater Lansing User Group for .NET. So sometimes we kind of wander outside that zone and talk about things that are not necessarily .NET, Microsoft.NET, but we're pretty much in there. And so I just want to mention that if you have any interest in Microsoft.NET, if you have any coworkers who have any interest in Microsoft.NET, we're on meetup.com/GlugNet, G-L-U-G-N-E-T. We got some really awesome speakers coming up. And one of the shifts we made, so GlugNet's been around since 2004. And I've been on the board since 2005. So it's been, it's hard to keep something that old, live and invigorated, right? But one of the shifts that we've made is that we've gone to remote speakers. So we have been able to snag some of the best industry names in the business to give up 2 hours of their evening and do a presentation to us remote. And so like on March, we have the leading expert on Entity Framework presenting to us from Vermont. This February, this month, in a couple weeks, the third Czech Republic, and he'll be speaking to us from Prague. So the presentation starts midnight his time. God bless him. So we're having some really, really good speakers. We're going to continue to do that, try to bring in the biggest names and the best presentations we can. So if you have any interest at all in Microsoft.NET, you or a coworker, just remember GLUGNET and find that on meetup.com and join. It's free to join, and hope to feed you some pizza when you show up. Okay, thank you.
Like Joe said, there are a lot of meetups in the Lansing area, and you can find a lot of those through lansing.codes. So that's the whole website. URL you need to type in is just lansing.codes.
And we're on there.
Yep. And there's a calendar with several of the different meetups. There are a lot of we dubbed them the Tech Tuesdays. There's also some stuff on Thursdays. There's also even some stuff, there's going to be, in, I think, 2 weeks, there's going to be the Agile group is going to meet here in the morning, same building. So lots of variety of different things. And also another really cool way if you want to connect with people in the tech community around Lansing is the Lansing Code Slack. So if you go to slack.lansing.codes, you can self-register, get yourself an invitation, and you can join that Slack group. We've got channels in there for most technologies you might be interested in. Some are more active than others, but it's a great opportunity not only to bounce ideas off your peers, meet some new people, but if there's a topic that you're interested in, something that you either want to present or something that you want to hear, you can reach out to any of the people there. Even if you don't know exactly which group it might fit in, just throw it out in the general channel out there, and somebody will try to help you out. So yeah. With that, I do real quick want to thank A2 Hosting. So they are, they've been a long-time supporter of Lansing DevOps, for food. Also, very nice for DewPoint to provide us this space tonight, as well as the additional beverages. We have lots of swag provided by DewPoint. There's some stuff from Tech Systems. Lansing Code Lab sponsored some stuff, and then the thing that I was really excited about that I've been staring at next to my desk for at least a month and a half now is the copies of the Unicorn Project that Gene Kim donated. So it was really cool to get that. So I'm excited for us all to be able to play some buzzword bingo here. And then I also want to call out next month for the DevOps meetup. We don't have a location nailed down yet, but we do have Dave Krakow from Split.io. He's going to come out and he's going to talk about feature toggle and feature flags and how they do that. So some of you were at the Launch Darkly meetup where we got to hear some of their perspective on feature toggle and feature flags and how you can have the slow rollout releases. And so we'll be able to hear Split.io go. His claim is it's going to be a little more technical, so it'll be kind of fun. I threw a couple curveballs at him to say, hey, what if you could explain how you would handle this scenario? So some of the like ring deployment and things like that are some kind of cool concepts that are technically very difficult. So with that, I'll go ahead and get us rolling. So my name is Brendon Thede. I work as a DevOps platform engineer. So right now I'm at Delta Dental, working on a Kubernetes platform there for platform as a service that's internal to our developers. And I am a continuous learner. I am constantly listening to podcasts, usually at 2.5 times speed, so I can get as many in as possible. I like to do a lot of Pluralsight and Khan Academy. And I also really enjoy community building, so I try to be very involved with Lansing Codes, so I can meet all you wonderful people and try to introduce myself and connect you with different people. And feel free to reach out to me either here tonight or through the Lansing Code Slack or whatever. And of course, the most important thing is we've got the buzzword bingo tonight. So this is how you can win all these lovely, lovely prizes back there. And if you don't have a bingo card, they should be kind of scattered throughout the table.
Do we have pens or anything?
Actually, if you want to, there are a bunch of pens in the bag. Tech System provided a bunch of stuff. So those ones you can just take. But the other stuff, if you get a bingo, call it out and then go back and pick out a prize. We've got the books, we've got a couple of Big B gift cards, we've got the towels and socks and the Dew Brew. So a lot of fun stuff. We're not doing any postage stamp or four corners or anything like that because I don't believe in that. That's evil. So you have to do your diagonal, horizontal, or vertical. And I'm saying you can only win once, but I have a feeling we might actually have some stuff left over at the end. This was awesome that people came through so generously.
Can we lead you in a direction to try to?
Sorry, I
ask your
can't do
question.
that right now.
I don't know what that
Yeah,
was
because
about,
if you're not fat, then you're what?
Not eating enough? Oh yeah, and I should back up just a little bit. There is a sign-in sheet. If you could at least write a name down there so we have a count, that helps us with our sponsorship. If you want to, you can provide your email address and that'll get you signed up for the Lansing Codes newsletter. So you get to hear about different events and sometimes we highlight different members of our organization and such. So without further ado, we are going to start off because you may be learning some new terms tonight. So you must all take the anti-jargonist oath. So this is where you promise not to use all your fancy new buzzwords to trick people into doing things they shouldn't. So I won't force you to recite this out loud right now, but just in your heart know that you cannot try to tell people you work with that they need to buy you this brand new Kubernetes cluster because you need to hyperconverge your Bitcoin blockchain so that you can utilize your functions as a service or anything like that. So none of that. That was an example of what not to do.
It did not help me at all.
Yes. So
So
what I'm going to do is I'm going to go through just a bunch of words. If you ever want me to slow down or anything, just let me know. And then I really hope that we have a lot of time at the end to talk and you can kind of ask deeper questions about how these things connect together. So starting our alphabet at
You guys
A.
want to sit at the table?
A is for architecture.
Got more room, 2 seats.
Yeah, feel free to come up if you would like to. So my reason for putting architecture on here is DevOps gives you a lot of flexibility. It lets developers move very fast. When you're implementing it the right way. But it doesn't mean you don't need to have some amount of forethought and planning to go into mature architecture. So you need to think about your system as a whole. Another A that might bite you is affinity, anti-affinity. So these are things that when you start trying to virtualize your workloads, you're now using, bare metal, you're using physical servers to serve a multitude of tasks. And you very well may need to split things up so that either they're spread far apart so they aren't interfering with each other, or you might want to group things together so that they have lower latency, lower connection times. A is for automation. This is my favorite one. This is what got me into the path that I'm on right now. I found things that I didn't like doing, and so I stopped doing them. So my goal for the longest time is to do as little as possible in my job, because I want to automate the things so I don't have to do it.
I'm telling your boss.
I always said that's why I got into programming, so I'm lazy.
Yeah.
Instead.
No, I'm optimizing, right?
Yeah, there you go.
And my last A is all the people, because DevOps is not just about tools and technologies, it's also about people. And so you need to make sure that even though, if you think about kind of the poster children of DevOps, like the Heroku type stuff where it's, the developer can just, npm install, some Yeoman package or something like that, and within 10 minutes they have their app up and running. Just because they can doesn't mean that they should, when you're in an organization where you need to be taking into consideration everybody's opinions. And so one of those big opinions might be the business. Most of us are going to be paid to do our job because we're generating some sort of value. Even if you're in a nonprofit, even if you're working for a government, there's an expected value. And so there's going to be somebody that's going to represent that value for you, and you need to really make sure that you understand that. You want to make sure that you're always communicating, and that needs to be a bidirectional communication. So you want to make sure that as you're coming up with ideas, that you're bouncing them off of other people in your organization. And you need to make sure that you're paying attention when they're presenting new ideas, not only to understand the direction that things are going, but to also sometimes give suggestions of alternatives or raise pitfalls up front. So we also have bandwidth. So bandwidth not only refers to your network, and how fast you can push bits across your wire, but it's also how quickly you can do things within your group. And so you're going to be limited by certain factors, and you need to understand those. And sometimes it means you have to slow down, so you aren't pushing the limits of your bandwidth at the cost of quality or any other types of things. And one of the ways that you can keep your internal bandwidth good is through controlling batch size. So this is one of those lean principles, comes out of Kanban and other systems before that. You want to keep work small. In lean manufacturing systems, they talk a lot about single piece flow. Maybe that's not the level that makes sense for you to get to, but you should be thinking about, how can we break things down so we can have the smallest experiments roll through that system as quickly as possible. And not only do we have batch size, but we have batch jobs. So you can, with your cloud service of choice, with your AWS, your Azure, your Google Compute, you can scale up your infrastructure, at the snap of a finger to ridiculous levels, to be able to solve all sorts of problems in the blink of an eye. But that might not make sense for everything. And so you might want to consider that not everything has to be real time. Not everything has to be, up to the second, instantaneous response. There are some things where it may be okay to let it settle for a while, let it run in the background as a batch job, and then you can save some money that way a lot of times. Okay, configuration management. So this is a very specific type of automation. So I'll differentiate a little bit. Infrastructure as a service is one type of kind of infrastructure as code. Configuration management I like to use it as a very different term because it usually means something different. And so while the infrastructure as code would be like managing, VMs, so saying what size that VM needs to be, how much RAM it needs to have, what disks it needs to have attached. Your configuration management is going to be more along the lines of, what apps need to be installed, what versions of, Python and what libraries does it need, and things like that. And so if you find yourself struggling with, different let's say versions of different things across systems. If you're somebody who has done any amount of development with Ruby, I'm sure you understand the pain of different Ruby versions being installed in different places. Configuration management can be a quick jumpstart toward some sanity there. Some tools I would suggest looking into are Ansible or Salt or Chef. Puppet is kind of the granddaddy of a lot of those. But if you're willing to invest some more time, one of the more common ways now to get that consistency across environments is through containers. And so I'm sure people have probably heard of Docker. Just so you know, though, they are not the only container game in town. There are lots of other options for containerizing workloads. But Docker is probably the easiest to get started with, due mainly to Docker Hub. If you search for Docker, you can find a million different 5-minute quick starts to be able to get it installed, download a container that runs some specialized workload. And by workload, I mean like a set of applications or services or things that are working together to achieve a goal. And containers are great because they are very resilient. You can kill them, they can come back, and you shouldn't have to ideally worry about any state that has changed. There shouldn't be anything that matters. And one of the ways that you can prove that that's working, as you expect, is chaos engineering. So chaos engineering is a concept that was popularized by Netflix. They started off with the Chaos Monkey, which did, very simply, just would kill VMs. So it would do this in production. It would just go around, it would find a machine that was running, and it would shut it down just to make sure that the system would recover from that. Because their system ideally should see that something, if it needs 100 VMs doing X and now it sees there's 99, their system should rectify that by saying, oh, I now need a new instance. And so it would bring that back up. Well, the chaos engineering world has evolved so much since that time, where now there's actually, if you want to find some really cool blog posts, if you look at Gremlin, they're a company where they provide chaos as a service. So they can do some really cool things if you install their agents, where not only can it just shut down a VM, but it can do things like introduce slowness into your network. Because sometimes it's really hard to differentiate in your application between, well, what is me connecting to service A is down versus it's just slower than usual, and how do you want to react to that? And so chaos engineering, the idea is that you're constantly stressing your system so that you can become resilient. And if that's a topic that interests you more, I am working on, at some point later in the year, I'm going to put together a hands-on workshop where we're going to focus on chaos engineering. Okay. Collaboration. This is something that should not be new to people who have been doing agile type software development. But this goes back to the idea of all the people. We need to get everybody together and talk through things, make sure we're understanding all the different perspectives, all the different expertise in our system. D is for data centers. So serverless is a lie. People have been throwing around the term serverless, but it is not serverless. It's just you care about the server less. So there is still a data center somewhere, and you need to understand what that means. There are physical limitations to things, and you need to take that into consideration. And there, especially as different data policies arise, different privacy policies. In the EU, especially, there's a lot of stuff around GDPR. Data management becomes a really big deal, and so it may make a difference. If you're using cloud service, you may have to control what country the data center you're using is in. You may need to be able to prove that data that belongs to a user that is in one country did not ever leave that country. I think Germany is a country that's doing that right now. So that's why there is a Azure Germany instance that's specific to them. Another thing to think about as you have the cloud sprawl that can ensue by having access to all the different fun toys out there is, kind of going back to that idea of architecture. Domain-driven design is a way that you can try to keep this under control, because as it becomes very easy to spin up a new service, a new API endpoint, stuff like that, it can also be equally as easy to get it to a point where it's not manageable. And some of us were talking earlier in the evening about how you manage database changes. That can be a little tricky because databases, there's a lot more at stake. If you get it wrong, you might lose data forever. If you don't have the right strategies behind that. Domain-driven design, the idea would be that you're keeping all the things that relate to a certain thing all kind of together, conceptually, logically, maybe physically, and that's going to help you reduce the blast radius of when you inevitably do make a mistake. And it also makes it so you can have loosely coupled architectures, so you don't have to coordinate, okay, we've got that one service that needs the new column in the one database, but that means we have to deploy 50 other things because they all need to upgrade their schema stuff, or the ORM tool isn't going to be compatible unless we deploy them all. Okay. One thing that I'm a big proponent of is declarative paradigms. So a lot of those configuration management tools, they use declarative paradigms. So the idea here is that you say what you want versus how you get it. If you've ever used SQL, SQL is a declarative language. You say, select these things from here, where this, that, but you're not saying, okay, open a file pointer to this partition on this server and now iterate over this pointer this many times to get to this. You allow the tool that is built to handle that type of logic better than most people would. You allow that to take care of that, and you can just declare what it is you want. You can get the same thing out of a lot of infrastructure tools, and it can become a lot easier to allow, a Ansible playbook, for example. You can tell it, hey, I need, this specific version of Node installed on this machine, and you just declare that that's what you need, and it will make sure that that happens. Versus the alternative would be, you say, okay, I'm going to connect to this machine, I'm going to see what version is there, I'm going to see if it's not the version I need, maybe I need to uninstall, then reinstall, or maybe I can do an in-place upgrade. You don't have to solve those things yourself if you can leverage some of these tools that are built for that in a declarative manner. Ephemeral. This is something to keep in mind with stateless designs. So if you're using stateless concepts, so the idea of it doesn't matter that a user was logged into a specific server, if they make one call and it takes them to server A, if they make another call and it sends them to server Q, it doesn't matter, right? If you've got stateless concepts, there shouldn't be anything that matters. And so it shouldn't matter if by the time they make the third call, both of those original services that they were connected to, they're gone, and now something else is in its place. This is this concept of everything's ephemeral. Treat everything as it's disposable. There's the concept of pets versus cattle. If you've got a pet server that you had to go out and after you did your normal provisioning, you had to install this and that, and you had to hand upgrade different things, that's your pet. We don't want pet. We want cattle. We want mass produced. We can replace this one with that one. They're all doing the same thing. We don't care as much.
You can slaughter them.
Yeah, eat them. They're delicious. Oh man, if I ate as many servers as I killed, I'd be not doing too well. And one of the concepts you can use around this is event-driven architectures, event-driven paradigms. And so the idea here is, kind of like that same declarative model where instead of having to think in your system, okay, a user came here and filled out this form, so I need to figure out what it takes to get it from here through this validation engine, through this other lookup, to then store it in this specific SQL Server instance, right? That's a fairly brittle design. What happens when you decide that you want to split that database because you're using a domain-driven design and you've decided that you want to split that out. If you want to do that and you've got kind of these hard-coded paths in there, it's going to be very difficult to change that. Now you've got to rewrite all your code to say, okay, I know we said it was this database before, this table before. Now it's actually this different table in a different database. Oh yeah, and the column structure changed. Event-driven designs are going to be very different. So if you've heard of things like Kafka, or RabbitMQ is kind of an older version of this idea of there's this message bus. And so rather than saying, okay, I want to write this thing that happened this certain way to this certain data store, instead you just say, something happened, and you publish that. And then other things that care about that thing that happened, they're going to consume that. They're going to subscribe to that event. And so that not only gives you a decoupling in your architecture so that you can now change out really foundational pieces, you can change them out and it's trivial. You can just change one spot where it cares about that. But you can also add new features in there. You can add new data warehousing and big data type stuff that isn't going to impact how your apps are already running. It'll be transparent to them. Okay. Equality is important. So the reason I have this here is the idea of there have been structures that I've experienced before in organizations where, and I'll just give this as an example. I've seen situations where it's the hosting team kind of holds the developers hostage to their whims. Maybe that wasn't actually happening, but boy, did it feel that way. The idea in any sort of a what do I want to say, the generative cultures. I was missing my word there. But in any sort of a generative culture, which DevOps is meant to be one of those, you want to treat everybody as equals. And so, whether somebody has expertise that somebody else doesn't or not, you should still come together as, our ideas are equally important, valid, even if they are a little bit, misguided. And so we should, instead of hold our opinion as better than somebody, we should try to explain to them why, what it is that they're not taking into consideration that made them think something that's different than how you see the reality. And sometimes even in explaining that, you'll end up coming to some different discoveries that you hadn't noticed before. And one of the things that can do is it can make us enabling. So that doesn't mean, kind of back to my earlier statements, this doesn't mean that you have developers able to just deploy all the things all the time, but they should have that ability. And if that's scary, then maybe there's some training that you have to do so you make sure people understand the consequences of actions. Maybe there's some extra automation that you need to put in, some quality gates, some checks that'll make sure that bad things aren't happening. But you want to do that as much as possible. Whether you win a free copy of the Unicorn Project or not, I really hope you check out the book. It's really cool. And one of the things that they really focus on there is functional paradigms and functional languages. So the idea here is that functions should be immutable. Functions don't have mutations in them. They don't have, pure functions won't have any state from one end to the other. And so it should make debugging your code much easier, right? Because you don't have side effects of any of the code that you're running. And so some popular functional languages, popular within the functional realm, I guess, would be like Scala, Haskell, Clojure is one that's fairly popular. F# if you're a .NET type person. I find them to be a lot of fun. I've heard some people make some statements about they don't like basically how you have to pass data, and there definitely are some gotchas. One thing, if you're somebody who wants to check out functional programming, look for some free courses online. I've done a couple through, I can't remember the name of it. I'll figure out where that was, and I'll share it in the meetup. But I did a Scala course It was really interesting finding out how some concepts around like tail recursion and things like that can greatly impact the performance of what seems like a very simple algorithm. But just because you can throw in a whole bunch of different languages doesn't mean you necessarily should. So familiarity is something you should consider whenever you're embracing any new technology. Just because Facebook is using GraphQL doesn't necessarily mean that you need to. Just because Google's using BigQuery doesn't mean it's necessarily the right fit for you. And if it's not something you're comfortable with, maybe you should think about what you're comfortable with first. And when I say you, I don't mean just you as an individual, but also anybody else who's going to have to support these systems going forward. Another thing, back to the equality and the ideas of getting everybody together in the collaboration, be aware that there are going to be times where it doesn't make sense to have every single person express every single opinion, right? And this can result in some fear of missing out. So that's the FOMO, And so you want to make sure that you find ways to value everybody's opinions, to give everybody a voice. But at the same time, that doesn't mean necessarily involving everybody in every single discussion, every single decision. So you have to find that balance there. Because you want to be able to move quickly, but still value everybody. And in any of the decisions you make, you want to be goal-oriented. I've seen some people who I've labeled it as resume-driven development, where they want to do the new hot tech because they're thinking that's the way that they can, throw that on their resume as, oh yeah, I did, Hadoop clusters in OpenShift, using, whatever Hive and all these different things, so they can put that on their resume so they can move on to the next place. Make sure that whatever technology you're bringing it in, you're bringing it in for the right reasons. And that's not to say that bringing in a new kind of sexy technology can't be a good thing, because sometimes that's how you can attract new talent. If you're building the same old Java apps the same old way that people have for 20 years, maybe that's not going to be as easy to bring in some fresh blood who want to do something a little more exciting with mobile development and things like that. So something to think about. I would say probably the hottest words right now is GitOps. I hear people talking about it all the time now. And the idea here is that you have everything is more pull-based. So every configuration, every manifest, every action you take is all in Git or whatever your version control is. And then you have inside of your system of record, or inside of your running systems, that's where you have it reaching out to the system of record and pulling stuff in. It's actually, if you want to learn more about it, Weaveworks, they're the ones who kind of originally coined the name. They've got some really cool tools, some really cool talks about that. It can be a very powerful paradigm. Governance, again, just because you can do something doesn't mean you should, and sometimes you might get punished very badly. So especially if you're dealing with EU or different state regulations around how you manage data, how you manage consent. I'm sure everybody sees all the million different cookie pop-ups now. Make sure you're following the rules. Hybrid cloud, because cloud is not just a thing that AWS has. You can have your own. Sometimes that makes sense. Sometimes it's due to technologies, licensing, whatever. There might be benefit to keeping some stuff on-prem. One of the kind of evaluations that I suggest to people is think about how much variability there is in your infrastructure. If it's very static, if you know that you need X number of servers running, this much RAM, this much CPU, if you know up front, you're probably going to save money if you already have the expertise to host it internally. If you've got something very dynamic and you can take advantage of dynamic scale, that's where a cloud, one of the public cloud providers is going to help you a lot. Hyperconvergence is a concept. So this is the idea of you've got all these physical servers and you want to be able to do many different types of work with that one thing. And in order to do that, you're going to use a hypervisor. So if you are using VMware, you're using a hypervisor. If you're using OpenStack, you're using a hypervisor. behind the scenes of AWS when they're spinning up EC2 instances, there's a hypervisor, and that's something that's going to manage the different workloads that are on your systems. And you want it to do that so you can provide isolation, right? So you want to be able to have it so that you avoid what's called the noisy neighbor. You don't want job A to impact job B. You don't want customer A to be able to inspect memory and see data for customer B. So isolation is a big thing. Idempotence. This goes back to the idea of ephemeral containers and stateless infrastructures. Idempotent is a word you hear thrown around sometimes. For whatever reason, the chef guys like to say the word a lot. All idempotent means is you can apply the same operation, the same function to something, and no matter how many times you do it, you end up with the same result. So like anything times 1, that's an idempotent function, right? If you multiply 5 times 1, it doesn't matter how many times you do that, it's still 5, right? So that's kind of the idea of whatever, if you have idempotent operations, it doesn't matter if you did it once or 10 times, it'll still end up in the same state. Infrastructure as a service. This is the idea of a cloud provider giving you VMs. So this is stuff that is more parallel to your physical infrastructure. So this is going to be stuff that feels very familiar to maybe the ways you've done infrastructure in the past. Some alternatives to infrastructure as a service would be platform as a service. So that's kind of like the type of stuff that I'm working on right now, where instead of giving people access to VMs, you just give them access to some sort of a service where they can push their app. And so they're still providing some special sauce. They're still providing some logic. Some business type stuff is going into that. But kind of on the complete opposite end of the spectrum from infrastructure as a service would be software as a service. And so that's like using, for example, Gmail. If you want your company to use Gmail to communicate internally, you don't have to write your own email service. And so the idea is that if there's something that if it's not something that is a differentiator for you and somebody else is very good at it and they're selling it, you might want to buy instead of build. And so there are lots of things to consider there, but don't assume that just because you're smart and you can think of how you might generate a certain solution, you might not want to. Insights. You always want to be getting information back from your system and capturing telemetry, capturing data, so you can make informed decisions about what the next best thing to do is. And just in time, but not just in time. Just in time. See, I want to make sure people are paying attention, right? So just-in-time provisioning. So this is the idea, kind of going, if we back up to the event-driven stuff, not only can you have event sourcing and event modeling to move data through your system, but you can have events that create new infrastructure for you. This is how you can take advantage of those public clouds and their ability to bill you just for the time that you're using something, and you can have it where rules say that, oh yeah, I only need this many servers if CPU gets up to this percentage, and then maybe add some more, or then if it's not been above a certain threshold for a certain amount of time, scale things down. And so think about that, especially if you're leveraging the cloud, a public cloud, because time is money in that case, and so you want to reduce your compute cycles as much as possible. Knowledge is code. This is my own thing. I made this up. So when everybody's talking about it in a year, you can say, I was there. Brendon said it first. So the idea here is that you need to make sure that not only do we have, here is the ARM template to be able to create these VMs in Azure. Here is the CloudFormation template for doing some stuff in AWS, and here's the Ansible playbook that can set up some systems, and here's the CI pipeline for deploying something. Those are nice things to have, but there isn't necessarily any glue holding those together. And so that's just little data points. You want that data to become information, right? And then from that information you want to turn it into knowledge. And so think about try as hard as you can sometimes when you're writing code, when you're documenting stuff, when you're doing anything. Try to think about how would somebody else consume this a year from now, 2 years from now? You want to make sure that it's not you as the single point of failure. And one easy way to do that is if you keep it simple. Sometimes if you have very clever solutions, that can also be very complicated. And so maybe instead of thinking through how you can, reduce some call time between these two services by introducing some extra, ridiculous layers of caching, if that makes it too complicated, that's going to make it very difficult to maintain. And so maybe it's not worth, if it's only saving you, 200 milliseconds of time each request. That's something to balance. Long running, long lived. These are things that you may not be able to avoid. You might have some things that, maybe you want to take advantage of functions as a service, right? So the idea of a function as a service is it only lives as long as it has to do its job and then it disappears. And that might make sense for certain things. There also may be times though where, because you got a bingo?
Yeah.
All right, good job, Attila.
You didn't say like a quarter of the words on my sheet.
So feel free to go back, pick out whatever prize you want.
Thank you.
Yeah, so functions as a service can be really cool. In theory, if you have something that is used at the right frequency, it can save you a ton of money if you're using a cloud, one of the public cloud providers, to just spin up something on demand. But there are also certain types of workloads. If you've got a streaming, video service, and people are hitting it all day, every day, it probably makes more sense to have something that's able to be up and running and long-lived, and you don't have to wait for that spin-up time. That cold start is a lot of times what you hear it called. But there are also times where it doesn't make sense to keep something around. So going back to the whole idea of having that insight into your systems, you might have some things that are up and running all the time, but nobody's ever using them. So you might look for ways to turn that off. Latency. We talked about bandwidth, on the network earlier. You can have the widest pipe in the world, but nothing's going to go through it until that first response. And so this is latency. And so if you think about different designs, such as microservices, you might think about having lots and lots and lots of different things in your system. And the thing you need to consider is network is not infinite, but even if it was, you still have the idea of latency. So there's going to be some amount of time, there are physical limitations on things, and so the more services you have in your chain, the more latency you're going to pick up. So maybe there's a cumulative effect where that's not something that you have a taste for. So just something to consider. And of course, microservices, they're on one side. The term monolith is on the other. Monolith typically has a very negative connotation. I don't think it deserves such a bad connotation, because there are a lot of times though where a monolith is very beneficial. I did a talk a few months back where I came up, if you're familiar with databases, there's the concept of the CAP theorem, which is that you can have consistency, you can have availability, you can have partition tolerance, but you can't have them all at once. Right? You have to optimize for maybe a couple of those at a time. So I came up with the DERP theorem. And the idea is you can optimize for debuggability, you can optimize for expenses, you can optimize for resiliency, and you can optimize for performance. But there's no way you can optimize for all of those concerns all at the same time. Right? And so that's where, depending on what it is you're trying to optimize for, maybe it makes more sense to have something in a monolith. If you want something that's going to be easy to debug and you want it to be super high performance, it's probably going to be a lot easier to do with a monolith. Certain types of things. If that's not your cup of tea, think about microservices, but don't assume that one is inherently better than the other.
Does anybody have DERP on their paper?
Oh man, I should have put that. That should have been like the instant bingo if you had DERP.
In the center, right.
Yeah. So to continue with DERP, the resiliency, you might need to consider multi-region. And so this is another one of those things where you have to pick what you're optimizing for. So multi-region, the idea here is if you are using a big cloud provider, or if you have your own data centers, if they are geographically disparate, opposite sides of the state, opposite sides of the country, that can give you some tolerance to different disruptions. If something happens on one coast and you've got a data center that's on the other coast, you can tolerate some things sometimes. And that can also help with, if you have customers spread across the world, if you've got, a content delivery network, a CDN across the globe, you can serve people faster, where there's stuff closer to them. But at the same time, if you've got data centers spread across the world, but you have certain things where you're not routing traffic right, you might introduce a whole lot of network latency. You might introduce a whole lot of slowness to get responses. And another thing to consider is if you're using a public cloud provider in particular, a lot of times you get charged very differently if you have data going from one data center to another, from one region to another. We'll call that data egress, and that's where it can become a lot trickier to understand your expenses. Mutation, I talked about this a bit before. Mutation, usually you think of it as a bad thing. I know the X-Men like to think that it always gives you superpowers and makes you really awesome, but not necessarily. Mutation can make things harder to understand, harder to debug, and so that's why functional languages try to avoid that. And so that's just something that you might want to pick up as a practice. Network policies. This is the idea around security. You want to understand what things can connect to what things. If you're virtualizing everything, it's not the same as, if you've ever seen like a network switch in a data center where you've got physical wires plugged in, it can be easier to at least visualize, okay, I have this wire connecting from this switch to this switch, therefore the only way that things are communicating here is this. So if I don't like what they're doing, I can pull that thing out and I know that it's done. In virtualized networks, it can be a lot different, and so you have to consider these things going into it. NoSQL, so this is, talking about the CAP theorem, there have been a whole lot of different types of databases to come out over the years. NoSQL is kind of this, flag that was raised. Depending on which mythology you want to believe, it started off as the one I like to believe anyways, is that it started off as a Twitter hashtag that stood for not only SQL, but people have thought of it as meaning, well, not relational databases, but it's just the idea of there's more than just a relational database. So if you're familiar with a MySQL or Postgres or an Oracle database, SQL Server, those relational concepts can work very well in a lot of scenarios. But there are also other scenarios where maybe you don't need relationships or you don't want them because they take too much time to retrieve your data. So depending on what you want to optimize for, you might look at different database technologies. This is where you might refer back to CAP theorem again to figure out what is it you want to optimize for. Again, there's no single best thing for anything, and it may be that you need to live with multiple data stores. That was the whole reason that Kafka was created. If you want to look into the event-driven CQRS is a thing you can look up. That came out of LinkedIn, where they wanted to be able to have multiple types of data stored multiple different ways, multiple different places, but they didn't want to have their systems be brittle. So you might have to be very hybrid. Native executables. This is fun. Java came out quite a while ago now. How old is Java now? Anybody know? It's not as old as me, but it's getting there. I think it'll be older than me soon. No. But Java, the idea was, well, we can write code once, but we can then compile it to this kind of midway point that can then be interpreted by a virtual machine running on this operating system, that operating system. With containers, with the idea that you have kind of all the libraries, all the runtime functionality that your system needs, it becomes a lot easier to now have native executables. These are things that are going to be optimized up front. If you've ever really dug into the Java runtime, you find out how it actually has to be up and running for some amount of time before it figures out, oh yeah, I need to optimize for this path. This is the hot path, so I want to make this go faster. And it's making those decisions at runtime. If you've got these ephemeral containers coming and going and respawning all the time, that's very inefficient. Because ideally, it's probably making the same decision every single time but it's taken it 5-10 minutes of being up and running before it's running at full speed. Native executables, through if you look at .NET Core, if you are a Java person and want to look for some things around getting better to native performance, you might look at Quarkus or GraalVM. These are some things that can make Java apps start up faster and kind of do some ahead of time optimizations. Open source, we rely on open source for lots and lots of things every single day. Make sure you understand the licenses. Kind of like I said with building things, just because you can build something doesn't mean you should. Just because you can download something from GitHub or wherever doesn't mean that you should use it, or depending on what regulations, what specific type of open source license it is, you might not be able to, you might not be allowed to. So make sure you understand, and these can be very tricky. If you're in an enterprise and you have an open source tool that you want to use, an open source library, hopefully you have some compliance people that can help you on your journey there, so reach out to some experts. Ownership. Not only do you have the ability to build things, but you have now a responsibility. You have an ownership of your things. So make sure you're thinking about the thing that you want to maintain. If you look at the SRE handbook from Google, they have, I think it's in chapter 3, they've got this pyramid of the hierarchy of needs of a service. And the idea there is you have to kind of be able to check off these checkboxes before you can get an SRE to support your app. Because if you don't have enough ownership to be able to say, yes, we have all these, we have all this plumbing in place, we have all these scaffolding, we have the fire alarms, we have the emergency exit, we have the airbags. If you don't have that and you don't have the ability to give confidence in somebody else to run your code, you're going to be responsible for it. So whether you're ultimately going to be the one getting woke up in the middle of the night or not, you should at least think about what would that mean? What is the code you would want to support at 3 a.m.? And your org structures.
This is the top result.
Oh. Your org structures, so if you think of, if you've ever heard of Conway's Law, I'm going to paraphrase it, and I'm sure somebody who knows it better will tell me I'm wrong, but it's basically, the communication structures within your organization are going to absolutely influence the infrastructure that you have and the structures within your org. And so the idea is, if you have 12 different developer teams working on a compiler, you're going to end up with a 12-pass compiler. Not necessarily a bad thing, but maybe if that's not what you want to look for, if you want your code to look a certain way, if you want your infrastructure to look a certain way, you should make sure that you're supporting that through your organization, and make sure that you've got that communication across different org responsibilities and such. Polyglot, so in your hybrid multi-container cloud, you have the ability to, if you want, have any number of languages. You can have some C#, and you can have some Lambda functions, you can have some Python, some Scala, whatever you want. Doesn't mean it's a good idea though. Think about, again, who are the other people on your team? Who are the people who are going to need to support this going forward? What is the support model for this? People, just like Soylent Green, it's people. So DevOps does not exist on tools alone. Platform as a service, I already mentioned this. If you are using a cloud provider or anything that provides platform as a service, it does typically give you a certain level of vendor lock-in, right? Because you're leveraging something that's specific to them, but it can free you up to move a lot faster. So think about what it is you want to optimize for. You want to optimize for, I can move to any other cloud at the drop of a hat, whether I ever will or not, or do I want to optimize for developer throughput? Quantum, another big buzzword lately. Google has declared their quantum supremacy, which IBM has disputed. Take it or leave it. It's something that may or may not be useful in the future. It's still a far ways off, so I wouldn't put all my eggs in that basket yet, because they might be rotten by the time it's ready to make my omelet. Query languages. This is not just SQL, right? So you might have to learn lots of different query languages to be able to efficiently pull some of that data out of your new systems. The Kusto query language is something that's becoming more popular within like Microsoft for getting into like their App Insights and some of their kind of time series based stuff. You might need to learn some of the Hadoop layered querying languages on top of that. These are things that will help you be able to better ask questions of your system and then be able to get answers back. Quantity versus quality. It's an optimization. Everything's an optimization. There's some times where you got to just get something done, and it doesn't really matter how robust it is.
Bingo?
Oh, you got a bingo? Awesome.
Yeah.
Congratulations. So feel free to go back and pick out whatever prize you would like.
Thank you.
Rolling updates. The idea here is you have infrastructure that's always up. If things are not completely ephemeral, replaceable, you might need to find ways to replace things in place. So this is going to be things like your OS patching. If you have a patch to the kernel of all your VMs and it's going to take a reboot, you need to plan that out. You need to think about that. And so you should probably think about that up front. These are the types of things where you want to think about it early and often. Disaster recovery is another one of those things where you want to be thinking through it. Whether you're actually having to do it every day, have it in the back of your mind as best you can in every little decision you make so you don't end up painting yourself into a corner. Real time, so the opposite of batch that we were talking about earlier is going to be real time. This is like maybe some streaming data, stuff like that. So there are going to be some things where you're going to want to have real-time insights. So there are some things where having data from 5 minutes ago isn't good enough. You need it right now. And where it's really going to be important is giving answers to your users, giving the experience to your users. I forget exactly the numbers, so I'll screw it up, but I'll say it was somewhere around the 3-second mark. That's where drop-off for users using like a web app or something. 3 seconds is the mark where they start having this exponential drop off. The bounce rate goes up, and they're like, if you look up some of the AWS metrics for for the Amazon.com site, it's like they have it down to like every half second of delay, they know how many hundreds of thousands of dollars that's going to cost them. So something to think about. But there also comes that point of, just like there's that exponential loss in revenue after a certain amount of time, there's also an exponential cost in getting too close to zero. So something to consider. Reactive. So this is kind of another way of saying event-driven. So you've got some stuff that's going to be reactive. So you've got that VM that's getting overloaded, so it knows to spin up another one. Sometimes that's going to be enough. As far as cost-wise, this is going to, if you can have new infrastructure spin up on demand, on the fly, fast enough, whatever fast enough means, that's going to be the most cost-effective, right? But there also are going to be times where you want to be proactive, because that 5 seconds that it takes to spin up a new instance is just too much, and you're going to lose money. So you want to proactively, based on the insights you're getting from your systems, be able to anticipate those things and do it up front. Software as a service, we already mentioned that. Man, I'm surprised there aren't more bingos. So the last time we did this, I think I had too few words on the bingo card, so we were like all done after the first 5 minutes. Man, I'm gonna have to just start throwing together gibberish statements here in a bit.
You haven't started?
Oh yeah.
I thought we were doing
jerk. Don't be a jerk. Single point of failure. Don't be a single point of failure. Try not to have single points of failure. It is really hard. If you think of your average system, it is, as you keep peeling back the layers of your onion, trying to find, okay, this is going to be redundant because of this. Well, what made the decision about those being redundant? Well, this, and this is going to be redundant this way. Okay, well, how is that redundant? What's the redundant system that keeps your redundant system redundant? And so you're going to have to come a point where you're going to have to spend lots of money or make some concessions. And sometimes having 100% uptime is not as useful as having a mean time to recovery of a very low amount of time. And that's one of the things that, if you look at the State of DevOps report that comes out, there's a couple flavors of it now. But if you follow that, one of the consistent findings is that the mean time to recovery, the MTTR, is way more important than the number of bugs and things like that. So if you have 99.999% uptime, for 1 year, then the next year you have that one little glitch that causes you to be down for a week, maybe that's not as important as if you had 99.99% uptime, but when you had an outage, you recovered within an hour or a couple minutes. Service catalog, ITIL wasn't all bad, and as you've got this sprawling landscape of software, applications that you're developing, applications that you rely on, it can be very daunting to keep track of all that stuff, but it is very important. You need to know not only for compliance and licensing and cost and consolidation efforts and things like that, but just human sanity and not trying to reinvent the square wheel because you didn't realize that you already had a capability that's already available. Silo versus SME, this is a very fine line. It isn't necessarily a bad thing to have somebody who is a subject matter expert, somebody who's really good at a very specific thing. What you don't want to do is create a silo out of that person. You don't want to have them be the dictator of all things related to a certain thing. So, make sure that as somebody is becoming an expert or staking their claim as an expert as something, make sure that they're also sharing knowledge with other people so that it isn't a complete dependency on them all the time. Support. You don't get away without support. So talking about that hierarchy of needs that the SRE handbook has in it, the second thing in there as their layers is support, the bottom being monitoring. So in Google's eyes, those were the two most important things, were monitoring and then being able to support your application. K for hypervisor. Copy, paste, fail. Don't be a jerk. T, throttling. So let's imagine you've got this super dynamic infrastructure in a cloud provider where it scales up new instances of your server for every 10 requests per second that it gets. It figures out that, if I'm getting more than 10 requests a second, I need to add another version. Or another instance. I need to add another instance. There may come a point where you're being DDoSed, not in the users not being able to get to your service sense, but in the you can't get to your credit card fast enough sense. So there have been, not as common as some of the other types of attacks out there, but there have been people staging financial attacks by just hitting people with a ridiculous amount of traffic so that their cloud bill is going to be really big. So one of the ways you can handle that is through throttling. So the idea there is that you want to have a certain maybe quality of service that you provide for different people. Maybe it's that you use a web application firewall, a WAF, to help keep that under control. But just keep in mind, network can be your friend. It can also be your downfall.
Would that be a scam by AWS and Google?
It could be. It could be. Same as ad fraud. There are some companies out there that were selling ads and then producing the clicks to go through the ads, and there are some shady people out there. I hope it's not Google or Amazon or Microsoft or any of them. Tracing. So the idea here, back to the insights. If you've got a microservices infrastructure, if you don't have distributed tracing, you're going to be in a world of hurt because you're never going to be able to know where things are, quote, slow. If a user tells you something is slow, that is a valid experience. It's not their fault that you don't know what thing is slow. So you need to make sure you've got tracing in your system so you can identify, when they say slow, what it actually is this call from this one thing that has the wrong URL, so it's trying this other thing 20 times before it gives up and then gives a default answer. Some other things you can do around that particular type of scenario is some circuit breaking. I don't remember if that's one of the words on there, but circuit breaking is a pattern where
Bingo.
If you have, cool, another bingo. See, it isn't necessarily all alphabetical. I can jump around.
They've got free pens.
Oh yeah.
Good stuff.
So circuit breaking is something that's a cool concept to look into. There are, if you're in a container world, there's Envoy is a network proxy that can do a lot of that for you. There are also libraries for most popular languages. TCP/IP, if you're writing web applications, this is kind of the big, sometimes bully on the block, but it isn't the only way to communicate. So just because you're used to, REST calls over an HTTP protocol, just because that's what you're used to doesn't mean that that's necessarily what you have to be stuck with. And so you might want to look into some different ways. Sometimes it's even just switching from a TCP, to a UDP type call. If you're not familiar with that, the difference there would be, guaranteed delivery versus, a little less overhead. It's also going to be different, packet sizes and things like that. So if you get to that point where, communicating from one service to another is limited by, the physical limitations of the wire, considering your communication protocols might be another way to try to optimize, versus, rewriting in different languages and things like that. Tech debt. Tech debt isn't evil. If
You say it's not evil?
It is not evil, not inherently. Now there is accepted tech debt. There is tech debt that going in up front, we are consciously making the decision to not do this way because of XYZ. It could be because of time, it could be because of cost, it could be because of licensing. The best tech debt is the tech debt that starts on your backlog. Right? The worst tech debt is the tech debt that you find inadvertently while you're doing something else. It's like, why did we do that? So tech debt isn't bad, but you should have not only a strategy for identifying it, and try to be conscious about it, but also a strategy for how you're going to address it. Because the debt in tech debt, that is very much like credit card debt, interest accruing debt. It's going to get worse over time. As you go further away from the time where you introduced that tech debt, your context is going to change. You're probably going to grow further and further away from understanding what the problem was that you avoided solving in the first place. User-focused. Everything we do, there's people. Well, most everything we do, there's at least people paying us, right? So think about who your users are. Those users can be customers. Those users can be people that you work with. Those users can be people who are secondhand, third-hand influenced by your stuff. But think about who your users are, identify them. If you're an agile type person, if you're a Scrum type person in particular, user stories have been a thing for a while.
You said my word.
All right, bingo. All right. So you've got your user stories, you've got your personas. These are all good ways to try to identify who your user is and try to empathize with them, have some empathy.
We can't get any of these.
Wait, do you just have to say the word, or does it have to be one of the words that's
I think you just have to say it.
If I say it, it's enough.
Yeah.
I'll. Okay, user space. So this is something to think about. If you have things, so in the standard, like in the Linux kernel, you've got system space. This is a gross overgeneralization here, but you've got system space, you've got user space. System space is the stuff where you have to be root in order to do any of those things. User space is where you don't have to be a privileged user. As much as possible, avoid having to do things as a privileged user. If you're running commands locally on your machine, if you have a Linux machine or you're using Bash or you've got a Mac, and if you're doing sudo a lot, that's probably a bad sign. If you're running on Windows and you're doing run as administrator, if you're having to do that all the time, probably a bad sign. If you can avoid it, do it. Uniform infrastructure. The idea here is you want to maybe have the same VMs everywhere, or maybe you don't. You need to think about what you want to optimize for. If it makes more sense to have Windows servers over here for this one thing and some Linux VMs over here for this other thing and some Raspberry Pis for a different thing, maybe that makes sense. There's going to be some overhead of the cognitive load of trying to keep all these things in your brain, in your headspace. Or maybe you want just, they're all vanilla, plain Jane, they're all exactly the same, they're all using the same OS. if you do have variability, I would definitely suggest doing it by workload type, so by the type of system you're running, by the type of application you're running, versus by environment. When you have different environments that you're going to promote your applications through, I wouldn't advocate for having huge differences in your infrastructure from one environment to another. It may be different in scale, but for example, I wouldn't say, okay, we want to run RHEL, Red Hat Enterprise Linux. We want to run that in production, but here, in every other environment, because we want to save on licensing, we're going to run CentOS. Maybe there are some differences that are going to be there, or maybe even worse. It's, we're going to do Ubuntu here, some Debian flavor, and we're going to do some Red Hat flavor over here. Maybe not the best choice. Virtualization, I'm pretty sure this has come up a few times before, but the idea here is, the physical thing, while that is good for a lot of stuff, that's going to be, the least number of abstractions, so you're going to have the fastest performance on, bare metal, if you hear that term thrown out there. Virtualization is going to allow you to have a lot more flexibility with that, security constraints, isolation, and all that. That dynamic infrastructure, that's all about horizontal scaling. So that's you come up with another instance, another instance, another instance. That can be very easy to react to, but it's not always the best choice. Vertical scaling has been popular in the mainframe world forever. And it isn't, don't believe the myth that it's because we don't have anybody who understands mainframes anymore, and that's why we can't shift off of them. It's also that for certain types of jobs, they're just stinking awesome. So respect that, and keep in mind that there are going to be times where vertically scaling, creating bigger things, is going to be more performant, easier to manage than creating many, many, many small things. So it's just another thing to consider.
Does monolith and vertical scaling go hand in hand, or there are different
It can be, so you can have a monolith that you horizontally scale. You can. But if you've got a thing that's always running at a certain level, maybe you don't need to have 20 of them. Maybe you can just have 10 of them that are twice as big. It's all about how do your physical resources map to your virtual resources? Because obviously you can't have, or you don't want to have, virtual things bigger than your physical things. I'm sure there are ways to make that happen, and it would probably be terrible performance. Mm-hmm. But at the same time, you probably wouldn't want, if you've got physical servers that you've got, like one VM. So let's say your whole infrastructure is 10 VMs. If you've got one VM takes up 3/4 of one of your physical hosts, that's dumb. That means you can never use that other remaining quarter. So you want to be able to rationalize these things to be able to optimize for your whole system, not just necessarily the one little piece. Visibility.
Bingo.
Oh, two bingos.
Represent this side of the table.
So visibility is one of the keys. So prior to the Unicorn project, Gene Kim and some other authors wrote the Phoenix project. In the Phoenix project, one of the key things that they keep talking about is visibility. It's all about seeing the flow, optimizing for flow. This comes from the lean manufacturing world, this idea of making everything visible. If you want to learn more about how to make things visible, value stream mapping is a good way to do that. And
Bingo.
sweet.
You said DevOps before, right?
Oh yeah. Well, that's the free spot. We're all DevOps. But yeah, so a guy who wrote the book, Learning to See, and several other books around the Toyota Kata, and some of these like visibility and value stream mapping stuff, is Mike Rother, and he works over at the University of Michigan. So he's very nearby, very vocal guy, very easy to strike up a chat with. So I've
Future speaker?
What's that?
Yeah.
I bet I could ask him that. I've actually ran into him at DevOps Days Detroit several times. Yeah. We've talked quite a bit.
Get him as a speaker.
What's that?
Get him as a speaker if
Yeah.
it's that close.
Yeah. Whole system. So whenever you optimize for the local optimization, you are almost exclusively going to be de-optimizing for the whole. So we want to look at the whole system. Make sure that you aren't just focusing on your little bit. This is where, so prior life, I'd gone through the ranks as a developer. I became a Scrum Master, became a release train engineer. One of the big shifts that I saw as we started to focus more on kind of a DevOps mindset was shifting from, Scrum was gold, and you focused on, the team has the stories going through as fast as possible. Well, that didn't matter if we're now creating this ridiculous backlog for, let's say, a hosting team or a security team that now has to review everything. And one of the things about Kanban, you limit your WIP, your work in process. What you want to do is have it where you see where your bottlenecks are. And I love how having a DevOps mindset, more of that whole system view, gives you more visibility into, this team, they're closing stories really quick, but they're not getting to production. Why are they not getting to production? Well, they're not getting to production because they have to go through the security review. Well, why do they have to go through this security review? Why are they getting held up there? Well, it's because they've only got 2 people doing this all by hand, or we've only got 1 license for Qualys or whatever system we're using. So you want to look at that whole system. Wire traffic. So this goes back to some of those physical limitations. The wires that are holding things together can only move stuff as fast as the speed of light right now. Until we figure out how to break that rule, we're kind of stuck at a certain level. Those wires also can be liabilities. If, for example, maybe let's say in Atlanta there's a data center and it's got redundant internet connections, but they're both right next to each other, and there's construction and a backhoe. Maybe something like that could happen, and you could lose all connectivity to your data center. So think about the requirements of being able to connect in and out, and how you can make that redundance. And I already said WIP. X, I'm cheating a little bit. So you might want an exact clone of production for testing your systems out. You might want it to scale. So that was that idea of, do you want uniform infrastructure, or do you want to have some variability? How close do you need to be to have confidence? Consider those things. And never forget about user experience. This is something that I'm working through in my day-to-day, is as I'm trying to build out a platform for users who are developers, it can be very easy for me to think, well, I was a developer once, I know what they want. Developers want this. They don't want to have to think about this. They don't want to have to decide on this. They want to be spoon-fed this, so I will give it to them. Maybe that's not the best way to do things. In the UI world, there are a lot of tools for measuring user experience and user engagement, and creating heat maps of where people are doing stuff on your forms and stuff like that. Maybe it's not as straightforward for some of your infrastructure provisioning type things, but think about ways that you can understand how are users engaging with your systems, and not only physically how are they doing that, but emotionally how are they reacting to that? Are you creating a pain for them each and every single day? Yesterday's data, sometimes it's good enough. Sometimes it's better. Oftentimes it's cheaper. But how long do you need to keep it? This is the kind of cesspool that big data without a strategy can become. If you think you need to hold on to data forever, there is a cost to that. And if you want to minimize that cost but still keep everything, you need to think about how you kind of going back to data management, how you can have different tiers of storage. If you look at all the major cloud providers now have these different levels of, there's like hot storage, warm storage, cold storage, and then there's the glacier. And oftentimes not only is the speed of retrieval different, but also the cost. A lot of times for that glacier storage, it's super cheap to keep it there, but the moment you want to read it, there's going to be a lot of cost for that. YAML. You can't have DevOps without YAML. Saw this just the other day. It was Patrick Dubois asking, what is the difference between DevOps and pixie dust? And then Matt Stratton responded with, YAML. I thought that was pretty cute. So. Another fun acronym, YAGNI. You ain't gonna need it. Don't assume that you need, every single, 3 layers of Redis cache with, some MongoDB on the side, and, keeping all the big data forever, with blockchain, who knows what. if you don't have a strategy for how you're going to leverage it, you're not going to need it. So keep your architectures loosely coupled so that you can, when you need it, integrate it. But don't assume you're going to need it. And I think I made this one up. I don't think I've heard it before. You be you. You build it, you own it. So this goes back to the ownership idea. Make sure that you are willing and able to support the systems that you inflict upon society. Zero downtime, going back to rolling updates. The idea here is, what is the cost of an interruption? Maybe it's not that big a deal. Maybe you have people who are using your systems from 8 to 5 every day, and there's really nobody using it outside of those hours. Okay, maybe building a zero downtime deployment model isn't the most profitable in that situation, because maybe it's okay to take an outage from 11 p.m. to 1 a.m. That also may, even if you can though, maybe that impacts your employee morale. Maybe you want to be able to roll out changes in the middle of the day when everybody's on their A game, everybody's there and available, and you don't have to make special arrangements. The ZAP pattern, this is one of the hardest things in declarative infrastructures, because it's the idea of, I can declare that I need 10 VMs, but what happens if now I only need 8? Depending on how those were defined, doing cleanup after the fact can be a little harder. And so that's where some newer concepts have come out around a ZAP pattern of, not only making sure that the things that you do need there are there, but the things that should no longer be there are getting cleaned up. Because if you're using the public cloud, it can be very easy to leave things out there dormant or semi-dormant, and then you get a bill once it accrues enough where they actually decide that they want to charge you. And then my reason for being here is I don't believe that this is a zero-sum game. So I don't want to work in any sort of a role where I am attempting to destroy every competitor. The whole reason I'm here is because I think that we can all build each other up and work with each other and have better opportunities individually and as a group, either working together or independently. So I don't think it's a zero-sum game. And then we've got some special bonus words. I don't know if people had these. IoT, right? Internet of Things. Intelligent Edge, the idea of moving your machine learning models into distributed systems like on farm tractors, things like that, whatever. Blockchain, it's not the answer for everything. My dad actually asked me once, he's like, so blockchain, is that like big data? I'm like, sure. If you want the most expensive, slowest way to store data, go with blockchain. It serves a very different purpose. Yes. And then service mesh. That is all the hotness if you're doing Kubernetes orchestration, stuff like that. Okay. So
Crappy bonus words.
Man.
We need more.
Further reading. So if you want stories told to you, the Phoenix project and the Unicorn project are similar in tone. The Phoenix project is kind of more from the management perspective. The Unicorn project is more from a developer perspective.
Well, I'd say it's more infrastructure focused and Unicorn project's more
Developer.
Yeah.
software focused
Yeah.
for sure.
Yeah,
So,
right. And some other things to consider are the 12-factor app pattern. This is something that has been around for quite a while. They've got some good principles if you can follow those. So that's some of those things around how you manage, ephemeral things, how you manage your configuration. Kind of gives you some best practices. If you're thinking about doing microservices, look at Martin Fowler's blog first. So he's, if you're somebody who wants to learn kind of what some kind of the thought leaders are in the DevOps space, or in just software in general, ThoughtWorks has a lot of good stuff coming out, and Martin Fowler's been with them for quite a long time. Jez Humble, who has done a lot, contributing to some of the DevOps Handbook and some of the other books that Gene Kim has done, he was with ThoughtWorks for quite a while too. And it's cut off there, but the Microsoft blog there, it's what is going off the side there as well as today.
Shared response.
Yeah. So what does shared responsibility in the cloud mean? If you just do a search for what does shared responsibility in the cloud mean, they talk about kind of they have this really good infographic of what the difference between infrastructure as a service, platform as a service, software as a service, kind of what that means, and versus completely on-prem. What is it that you're responsible for at the different layers? And spoiler alert, you never get away from being responsible for some level of security. You always. So even if you're using Salesforce to do a whole bunch of stuff, you're still responsible for making sure that you have good password policy and you're not, posting your username and password onto Twitter or anything like that.
Checking it into source code or whatever. Right.
Okay. Any questions? Any leading questions that people want to get a bingo?
You say the word telemetry.
Can I did say telemetry.
Okay, thank you. Bingo.
All right. Yeah, so I know I talked kind of fast for a lot of things, but my goal here is that I'm hoping people will go away with some ideas of different things that they want to learn more about. And if there's something that you really find interesting, let me know. We can have whole topics around things. Just like Joe, I try to bring in interesting, intelligent speakers from all around. Sometimes I get better luck than others. Sometimes you're stuck with me.
All right, very good. Thank you.
Thank you.
There's a lot of topics.
Yes. I did kind of the speed version.